Hey guys, so today is gonna be a short class. It's going to be a little simple, easy concept. This concept is something that you need to know to understand the salts that are going to come ahead. So we'll be doing a little bit of magic in today's class. Okay, just kidding. It's not magic as such, but you know, there's a saying, magic is nothing but science that you don't understand yet, right? So maybe what I'm doing now, at some point people thought, wow, that's magic, but now we understand it, so it's just science for us. All right, so we'll get ahead with it. The topic we cover today is called as water of crystallization. Okay, big name but quite a simple thing. So to understand this, we'll be doing a small activity with the salt that we are familiar with. Okay, we have seen this in our previous activities. It's called copper sulphate or cupric sulphate. If you remember, it's a blue colored salt, crystalline, right? Great if you remember. Here it is, our nice blue, beautiful, pretty little salt. Okay. So I know that the salt is blue in color, but why is it blue? Because that's his favorite color. It's my favorite color? No. Right. What I'm going to show you is how do I change the color of the salt. Right. Of course, we know one thing, that changing the color is one type of a chemical change generally depicts, right? Not always the case, but yeah, let's take a look at it. So to start us off, what I have done, I have taken this some amount of salt in my flask. Okay, there's like a couple stones, that is fine. All right, so what I'm going to do now is I am going to heat the salt a little bit to see what it does. Alright, so I'll just come here, open the spirit lamp. It is a spirit lamp. If you haven't seen it in our activities before, it has a chemical that burns. So I'll just put some water here. Alright, okay, this match is gone. Alright, so now we have a lamp that burns. Alright, see, it's got an odd colored flame, right? Alright, so I'm going to be heating this flask over this, and hopefully we'll be able to see a reaction. Alright, okay, then let's start. By the way, it's ideal to do these kind of heating tests on something that we call a test tube. Must have seen it in some activity before. My test tubes are broken, so I won't be doing that now. Still works with this. Alright, so I just want you to keep on observing this flask as it keeps getting heated. Okay, there's going to be some change in the flask or in the salt, right? It might take a while, but it should be quite an evident change once you see it. By the way, blue is my favorite color. Kind of like it. It's also kind of why I like the salt so much. But yes. Alright, I think it's starting to happen. Alright, I think it will be a little more evident in some amount of time, but if you're looking from that side of the camera, you'll start to notice it's starting to change its color at the bottom. A bit, not much, but yes, a bit. Let's give it some more time. Okay, now if you see, there is a bit of moisture inside the flask. I'm not sure if it's very clear, but there is some moisture coming. And you know what moisture means, right? Just water, right? It's evaporating and it's condensing inside of this flask. Now where is this water coming from? Is a question, right? So there are a couple of salts that hold something that we call as water of crystallization. Okay, crystallization as in it's generally found in crystal salts, so salts that are in a crystal shape. Remember we spoke of two types of salts, amorphous and crystalline. So crystal salts are nothing but crystalline salts. Okay, now these crystal salts sometimes they'll hold some amount of water with them. Okay, and that water is what I'm trying to release out of this copper sulphate, because this is one of the few salts that can contain water. More salts you're going to be studying in the class that goes forward. Right, you must be starting to notice the paleness of the salt, right? Look at the base of the flask. You see the salt has become white there, right? I'm hoping you're able to see, right? I'll just keep on heating this for some amount of time until at least a visible amount of salt is white, right? So as we heat, like I was saying, this salt of this water in this salt is slowly getting evaporated, right? It's getting thrown out of this salt and it's just kind of going up in vapor. Right, now every crystal of salt that loses that water will change its color, at least in the case of this copper sulphate. This is why you are able to see some crystals have become white, the others are blue still, those have still not heated up, right? The moment I start to heat, they start to catch more heat, you'll see that even they are going to become white in color. Right, now if you see even from the top, you'll see that all this bright blue salt has started to become almost white at the back, and even through this, those two big rocks are taking time, but you'll see the salt is starting to go pale and becoming white. Now all of this whiteness is because that is what the salt is going to look like if the water of crystallization is not present inside of it. Right, so what happens is whenever this crystal meets water, it kind of forms a bond with the water. Okay, not exactly a chemical bond, but they get attached to each other. Okay, and that can be shown when we write the chemical formula of this salt. Right, so when we say chemical formula of the salt, I'll just quickly show you this label. Right, if you look at the label, notice the formula of the salt. Right, I'll try to take a clearer picture and show you later, but for now take a look at the okay, it says CuSO4.5H2O. right, we know copper sulphate is CuSO4, but it's also mentioning .5H2O. The .5H2O is the water that is present with the salts. So what that tells us is this dot is shown to tell that one copper sulphate molecule is attached to 5 water molecules. Okay, so if there is one molecule of CuSO4, it's kind of surrounded by 5 water molecules all around it, and because of that kind of a bond this color is there. Okay, this color is present because of the water that is present inside of it, and 5 is a lot of water, right? So you will see that, yeah, most of my salt is now white. Now this change is reversible, right, which means if I heat it, it's going to lose its water, but if I simply add water back, that is going to bring the color of my salt back. So what I'm going to do, I'm going to take this like slight cap full of water, and I want you to watch the salt as I watch, look at the salt, it's slowly gaining the moment the water touches it. I have added the water, and now I'll just give it a good shake, and now my crystals are all blue again. I think the water is a bit excess, but doesn't matter. See that there's no more white salt in it, right? Everything's become blue simply because I added water to it, right? So the chemical reaction for it goes like this: CuSO4.5H2O. On heating, it gives rise to CuSO4 plus 5H2O, right? Then just the dot breaks and they become two separate compounds. Now I'm telling you it's not a chemical change exactly, because whenever we see chemical change, say for copper sulphate, the copper and sulphate break and something else comes in the place of copper or sulphate, right? But this is not that. It's just two different molecules that attach together and can detach when heated, right? There is no interchange of any atoms or anything in between them, which is why it's not exactly chemical process, but yes, it is still something quite fascinating and quite beautiful to look at. Right? Going forward, tomorrow we are going to look at two more salts that actually have water of crystallization in them, and I'll be seeing you tomorrow. Small activity, small topic. I hope you understood. I'll see you in the next one.